Good morning, students. This is your Maths 1 online teaching session. Today, we will continue with our second chapter, that is real numbers. Today, I am going to teach you a concept based on comparison of surds. Okay? Now, when we want to compare any two surds, what are the important things to remember? The first thing is, only like surds can be compared. Now, see this. If root A and root B are like surds. Now, what do you mean by like surds? We have already done this, like and unlike surds. Like surds means those surds which have same order. See, this is square root, this is also square root. So they are like surds. So the first thing is, we can compare surds when they are like surds. Okay. Now, comparison is also based on these three different points. Either they can be equal or greater or smaller. Correct? Now, how do we find that? See this. Square root of A is equal to square root of B if the number written inside the radical sign is same. A is equal to B. See the example. Square root of 5 is equal to square root of 5. Obviously they are equal. Order is same. Square root, correct? And the number inside the radical sign is also same. Then we can conclude that the surds are equal. Second condition is square root of A greater than square root of B if A is greater than B. I hope you are understanding it. We are only comparing the number inside the radical sign. 7 is greater than 5. So what I can say? Square root of 7 is greater than square root of 5. And the last condition. Square root of A is less than square root of B. When I can say this? When A is less than B. Look at this example. 7 is less than 15. So what I can conclude? Square root of 7 is less than square root of 15. I hope this concept of comparison of surds is understood to you. Either they can be equal surds, it can be greater than or lesser than. Yes, based on this concept, we are going to continue with our exercise sums. Now see this. Practice set 2.3. We have already started with it. Today from that exercise, we are going to deal with such type of questions where comparison of surds is done. See the first one. 7 root 2 and 5 root 3. Now, which type of surds is this? We have finished this in the previous session. I hope you remember. These are mixed surds. 7 root 2. There is an integer part and a root part. So, such type of surds are called as mixed surds. Unlike this, see this. These are pure surds. Square root of 247. There is no integer part here. Square root of 274. There is no integer part here. So, these are mixed surds and these are pure surds. First thing is, whenever you have to compare surds, never try to compare like this. We are going to convert it into a pure form. I am going to take this 7 inside this root sign. Okay. Now what is the method for that? For that, if I ask you square root of 49, what will be your answer? Square root of 49 is 7. Correct. So when I want to take this 7 inside, it will square itself and go inside. See, 49. 7 is going inside, it will become 49 square of 7 into 2. So that is square root of 98. Okay. Similarly this 5 is going inside this radical sign. So it will be square of 5, that is 25 will go inside. Because square root of 25 is 5. So when this number goes inside the radical sign, we have to do the other way. We have to take the square of that number. So it will be 25 into 3, that is square root of 75. Now these are pure surds and we can compare these numbers. Since 98 is greater than 75, I can conclude square root of 98 is greater than square root of 75. But from where do I get the square root of 98? I get this from 7 root 2. Square root of 75 from 5 root 3. So that is what I will conclude as my final answer. That is 7 root 2 is greater than 5 root 3. I hope now the concept is clear to you. Yes, what are the basic steps? First, convert the mixed surd into a pure surd. Once it is done, you can compare the numbers inside the radical sign and put that equality, inequality sign, whichever, and then accordingly conclude the final answer. Okay. Now look at the second question. It is much easier than the first one because there is no integer part here. They are already pure surds. I just have to compare these numbers. Since 247 is less than 274, square root of 247 is less than square root of 274. Like this, we can directly write the answer of it. Okay. See the third sum. 2 root 7 and square root of 28. Now this is a mixed surd and this is a pure surd. So our first step is what? To convert this into a pure surd, correct? So 2 root of 7. This 2 will go inside the radical sign. What should I write? Square of 2. 4. So 4 into 7, which is nothing but square root of 28. I got here square root of 28. Question also, it was square root of 28. Since 28 is equal to 28, I can conclude that they are equal surds. So all the three properties which I have explained you in the previous slide are applicable here. This is greater, this is smaller, and this is equal. I hope the concept is clear to you. Yes, this is a way how you will compare the surds. Okay, let us see the next question. The next question is question number 6 from the same practice set. Now I have selected this C. 5 root 3 and 9. 5 root 3 is a surd, okay, but 9 is an whole number. Yes, 9 is a number. Now I cannot compare a surd with a whole number or a natural number. Whatever you want to say, you can say. But it is not a surd. 9 is not a surd as such. So I cannot compare like this. So what should be done? First step, let us see this 5 root 3. It is already a mixed surd. Let us compare it into a pure, convert it into a pure surd. What is to be done for that? 5 will go inside this radical sign and will become 25. So 25 into 3, how much? Square root of 75. Okay. Now what is to be done with this whole number? I am going to convert it into a surd. I hope everybody knows this. 9 is nothing but square root of 81. Yes or no? Do not write 9 as square root of 3. We are not taking square root of 9. We are taking this 9 inside the radical sign. See how we do? When 5 goes inside, we take 25. Same way, when 9 is going inside the radical sign, it should be square of 9. That is 81. Now you can very well compare these numbers. 75 is less than 81, correct? So from where do I get the 75? 5 root 3. So 5 root 3 is less than 9. I hope this concept is clear to you. When it is a whole number and a mixed surd to be compared, the first step is you convert this whole number into a surd like this. Suppose I give you here 7. So what are you going to write here? Square root of 49. Yes, you will square that number. Don't take the square root and write 9 as root 3 here. That will go wrong. Okay. Same type of sum is the next sum, that is question number 7, which I would like you to do sincerely on your own. 7 can be written as square root of 49. 2 root 5 can be converted as 2 will go inside, it will become 4. So 4 into 5, square root of 20. Now you can compare these two. 49 is greater than 20. So from where do you get that 49? 7. So 7 is greater than 2 root 5. Exactly same type of sum, both from the practice that I have taken. I hope this concept is clear to you. Yes, please write along with me, otherwise you will really not understand. I hope all are writing in your notebook. Okay. After this, we are going to take one more important topic, that is operation on surds. Now operation on surds means what? What are mathematical operations that can be done? Addition, subtraction, multiplication and division. What I need to remember for this, I need to remember that this mathematical operations can be done only and only on like surds. Okay. So I have given you a condition to think about, right? Is square root of 9 plus 16 equal to square root of 9 plus square root of 16? Yes, just think about it. Are they equal? Yes, let us see the solution of it. Square root of 9 plus 16 is nothing but square root of 25. And square root of 25 is 5. When I go to the right hand side, square root of 9 is 3. Square root of 16 is 4. And 3 plus 4 is 7. Are they equal? No, they are not equal. So this is a common mistake which is often done in surds. Do not try to individually take their square root and add. This cannot be done as 3 plus 4, 7. When they are separate like this, yes, then you can take it individually their square root and add. But when they are together under the root sign with an addition sign, yes, these two numbers are together inside the root sign. So you first add it. Whatever answer you get, take the square root of that. I hope this concept is clear and you have understood your mistake and you will not do it again. Yes? Okay. With this note, we will continue with our next question of the exercise, that is simplify. Question number 6. See this, 5 root 3 plus 8 root 3. I just now told you addition, subtraction, everything can be done only on like sorts. Are they like sorts? Root 3 and root 3. Yes. So that can be taken common. And integer part can be added. 5 plus 8. Correct? So 5 plus 8 is nothing but 13. So answer is 13 root 3. Do not do the mistake of writing 13 root 6. Many intelligent students add this also, root 3 plus root 3. Please do not do that. That has to be taken common. And only the integer part is to be added. So the answer is 13 root 6. Okay. See the next question. 9 root 5 minus 4 root 5 plus square root of 125. First thing is, this is a mixed surd, correct? This is a mixed surd, but this can be further simplified. So my next step is only to do that. 125 can be written as 5 into 5 into 5. Since this is square root, this 2 can be grouped together and what will come out as 5. This root 5 will remain as it is, correct? Now see this, root 5, root 5, root 5. That can be taken common. Add and subtract the integer part. What is that? 9 minus 4 and plus 5. 9 minus 4 and plus 5 and root 5 common. Correct? So 9 minus 4 is 5. 5 plus 5 is 10. So answer is 10 root 5. Again, don't do the mistake of writing here as 10 root 15. Don't add this radical, this surds. Okay? Only add the integer part. So 9 minus 4 plus 5 is 10 and answer is 10 root 5. I hope this sum is clear to you. Yes? Okay. See the next question. Root 7 minus 3 upon 5 root 7 plus root 7. Now there is no problem in this sum except that this is a fraction. Don't get afraid at all. First thing is root 7, root 7, root 7. Take that common outside. Yes, root 7 common. Now from here if I take root 7 common, what will be left? Nothing left, see? So I am writing 1. From this part if root 7 is common, what will be left? Minus 3 upon 5. From this part if root 7 is taken, plus 2. I hope you understood how this step we got. We are taking root 7 common. Inside the bracket, since here nothing is there, 1 we will write. This is minus 3 upon 5 and this is 2. Okay. After this, add the whole numbers. 2 plus 1, 3. Okay. Minus 3 upon 5 and then root 7. Now this can be cross multiplied. 3 5s are 15 minus 3 upon 5. I am cross multiplying it. This is nothing but 3 upon 1. Then you cross multiply, you will get this. And 15 minus 3 is how much? 12. So we get 12 upon 5 root 7. I hope all the steps are clear to you. It looked complicated, but trust me, it is very easy. Yes or no? I hope you are also finding it easy. Take root 7 common. Inside the bracket, take the numbers, add and subtract, get the final answer. Okay? Okay. So with this, we come to the end of this session and I have included few assignment sums for you. These are nothing but 1 or 2, 3 sums in fact, which are left from the practice set itself. These are not extra questions. So once you finish writing all those sums which I have done today, I want you to write it like this only in your notebook also as assignment and solve it. If you have understood whatever we have done, you should be able to do this. Yes, nothing different I have given you. I have just included 2 types, compare and simplify, which I have done in today's session. Right. So with this, I come to end of this session. Remaining, we will continue in the next session. Yes. And you will complete your book also. Keep your books complete. We will continue in the next session. Thank you.